All right, so hopefully everybody's having a good day. Today we're going to be talking about rates, proportions, using units. So a lot of, you know, kind of real world application word problems today. So let's go ahead and take a look at our first one. So we have a large TV screen, or large screen TV that originally sells for $900 is marked down to $684. What is the percent of decrease in this price? All right, so the first thing we should do is figure out how much the price went down by. So let's do, oh, pen's not working. 900 minus 684. And that gives us what, 116? Good. So that means it's $116 off, right? That's what that number is telling us. So now we want to find the percent of decrease, and we do that by dividing the reduction price by the original price. So we want to say, all right, we went down by $116, and the total was 900. So we're going to find our percentage here. So we divide that, use your calculator. You can do it by hand if you just really enjoy doing math, but you get 0.24. So we need to understand what that means. What does that mean? So, well, to get it into a percentage, we got to move it 2 decimal places to the right. So what this is telling us is that we have a 24% decrease in price. And so if you wanted to check your work and make sure you did it correctly, you could take the original price minus the original price times the percent of decrease, the 0.24. Remember, when we use percentages in calculations, we need to move it over 2 decimal places. And if you type that in your calculator or do it by hand, you do get $684. That's telling you we did it correctly. All right, so this example, we got Tom, Dick, and Harry are friends who go shopping. Tom buys a shirt for $25. Dick buys a shirt for 15% more than Tom's shirt. Sorry. And Harry buys a shirt for 20% more than Dick's shirt. What is the combined cost of all 3 shirts? All right, so, I don't know in the real world if you'd ever have to figure out how much Tom, Dick, and Harry spent on their shirts because from when they went shopping, but let's figure this out. So we know Tom's shirt was $25. Oops, pen's not working again. So we got $25. That's Tom. So now we need to figure out how much Dick bought the shirt for. So how would we do that? Well, using what we just did last time, what we're going to do is Dick's is $25 plus 15% more than $25. So we're going to have 25 times our 0.15. So that's how much Dick paid for his shirt. So Harry got the worst deal out of all of them. He paid 20% more than Dick's shirt. Well, it looks like I probably should go ahead and work this out then. I need to figure out that value because that's going to make my life a lot easier to figure out how much Harry's shirt was. So if I work this out, that gives me $28.75. I type that in my calculator. So now we got Tom's is $25, Dick's is $28.75, and now Harry's shirt is 20% more than Harry's. So I'm sorry, than Dick's. So we're going to have plus 28.75 times 0.2. Another parenthesis in there. There we go. All right, so if we work this guy out here, oh, pen's not working again. There we go. That would give us, what does that give us when we type it in? 34.50. So now we can just bring out all of our other numbers. So now we know how much Dick and Harry's shirts are. All right, so We add all that up and we get a total of 88, whoops, it's a horrible 88.25. So that's the total price paid by Tom, Dick, and Harry. All right, so we got a man making an annual salary of $80,000 a year, gets laid off, and is forced to take a part-time job paying 60% less. So what is the salary for his part-time job? All right, so there's a couple different ways to go about this. So the way I'm showing you is not the only way to correctly find the solution, but this is how we did it in the previous example. He was making, $80,000. And we need to take away some, from that 80,000. And it said he is making 60% less. That means we need to take 80%, or 80,000 times 0.6. We got to move there 2 decimal places. And what does that give us? That means he is now making $32,000 a year. It's a big pay cut. All right. So the next problem we got, suppose the man is making X dollars per year instead of 80,000. What is the salary for his part-time job in terms of X? So let's go ahead and take a look at this. Pretty simple because you just did A. So all we're doing here is replacing the 80,000 with an X. So we're going to have X minus X times 0.6. So now, we could simplify this a little bit more here, I think. And I don't like where I put that 0.6. So I'm going to have X minus 0.6X. Well, now we have like terms here. What's 1X minus 0.6X? 0.4X. So now we could easily calculate if his salary was different by plugging it in for X. So example 4 here, we got a group of students take a van to a football game. They average 20 miles per gallon on their 155-mile trip. How many gallons of gas did they use? All right, so let's just kind of set this up here to make sure we understand what we're doing. So I'm going to be lazy. I'm not going to write gallons. We're just going to put gal. And I'm going to put an M for miles over. That's a times. Handwriting's horrible on this. Gallon equals miles. And hopefully that makes sense, because we can see that the gallons, one in the numerator, one in the denominator, would cancel each other out or reduce to 1 here, so we get miles. So what we need to do here is figure out what we know. So they average 20 miles per gallon, and it was a 155-mile trip, right? So we need to figure out how many gallons we have here. And we have, 20 miles per gallon. Whoop, pen stopped working again. So I'm going to put my 20 miles per gallon here. Equals the total number of miles, the 155 that we drove. So now we just need to, divide both sides by 20, right? And we get X equals 7.75 gallons. And we are done. And so here's a little bit more, I think, complicated problem, because there's more conversions going on. So we got a car that's going 66 feet per second. How fast is the car going in miles per hour? So we need to set all this stuff up. Well, our feet per second here is the first one. We know that the car is going 66 feet per second, so that's where that one's coming from. And then we need to do times how many seconds are in an hour. Well, there's 60 seconds in a minute, and there's 60 minutes in an hour, so 60 times 60 is 3,600 seconds in an hour. And now we have to do how many miles are per feet. So we have 1 mile per, 5,280 feet per mile. And then we have it equals, what we got? So it would be a great time to type all this into a calculator, and it looks like we get 45 miles an hour.
Call the crap out of the kids individually?
All right, so next question is, we got Romeo and Juliet have a lover's quarrel. Juliet bolts away due east at 5 feet per second. 1 minute later, Romeo stomps off in the opposite direction at 4 feet per second. How far apart are they 3 minutes after Juliet leaves? Wow, this is an amazing problem. All right, so with this problem, we're going to need to break it down into two parts by calculating the distance that Juliet travels and adding the distance that Romeo travels. So Juliet travels 3 minutes, and we first convert that into seconds. So how many seconds are in 3 minutes? And I hope you guys are already, yelling this. So it's 180 seconds, right? All right, so 180 seconds. So now we need to figure out the distance that Juliet travels in 180 seconds. Well, if she goes 5 feet per second, I'm going to put this right here, Juliet. She goes 5 feet per second and she walks for 180 seconds. How many feet did she walk? So we type that in and we get 900 feet. So we know Juliet bolts away for 900 feet, I guess I should say. She didn't walk away, she bolted. All right, so now we got to figure out how far Romeo traveled. So Romeo is a little bit slower, right? He went 4 feet per second. And then, all right. So what we got here? So since Romeo waited a minute to stop off, what we got here? How many seconds? That would be 120 seconds, right? So we'd have 120 seconds. So now he only went 4 feet. He wasn't as fired up as Juliet was. So we got 4 feet times the 120 seconds. And what does that give us? 480 feet. So now we need to figure out how far apart they actually are in total. So what do we need to do here? We need to add two numbers together, correct? So we got 900 plus 480 would give us 1,380 feet. So that's how far away Romeo and Juliet are from each other after their lovers quarrel. All right, our next example here, we got the recommended dose of a certain drug to be given to a patient is proportional to the patient's weight. If 2 milligrams of the drug is prescribed for someone weighing 140 pounds, how many milligrams should be prescribed for someone weighing 180 pounds? So let's round your answer to the nearest hundredth of a milligram. All right, so let's go ahead and set this thing up. So we're going to do proportions here. So we're trying to figure out how many milligrams a 180-pound person should take, right? And we know that somebody takes 2 milligrams and they weigh 140 pounds. Whoops, and I write a G. All right, so what do you think we need to do here? Exactly right. You can think of it as cross multiplication. So you could this times this, because it's what 140x equals this times this, give us 360, right? And I was a little lazy, but everything kind of cancels out, so we don't have to worry about the measurements here. So now we just got to divide everything by 140. Ran out of room. And what does that give us? So it looks like about 2.571, blah, 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 right? And it wants us to round to the nearest hundredth. So let's go to the hundredth, that's the 7. So since there's a 1 behind the 7, we're just going to keep it at 2.57. So x is approximately 2.57 milligrams. That's how much this person should be taking of this drug. All right, we have finally made it to the last problem in this section. So Jack and Jill both work part-time jobs at the local burger barn. Where did they come up with these names from, right? Yeah, Romeo and Juliet, Jack and Jill, Tom, Dick, and Harry. Okay, so Jack makes $2 an hour less than Jill, and he works 5 hours more than Jill during 1 week. If Jack makes $7 more an hour and works 22 hours, how much do Jack and Jill combined make in dollars that week? All right, so let's go ahead and start working this thing out. So What is it? Jack, so we're on A. What do we got? Jack makes $7 an hour, right? So I'm going to put 7. I'm going to be really, really lazy. So dollars per hour, right? That's what that represents. And he worked how many hours? 22. So 22 hours. And then, what else do we need to take into account here? And Jack makes 2 hours less. So that means Jill has to make $9 an hour, right? So in dollars per hour. And then how many hours did she work? Oh, she works, what, 17 hours because she works 5 hours less than Jack, right? So let's go ahead and kind of hack this all out. So 7 times 22 plus 9 times 17, that gives us what, about $307, right? Again, since we left the labeling on here, the units, our hours, really what happened here was our hours canceled out because hour on top, hour on bottom, hour on top, hour on bottom, reduced to 1. So we noticed we were only left dollars. So that's why the answer is $307. All right, so problem B here. Jack makes R dollars per hour less than Jill, and he works H hours more than Jill during 1 week. If Jack makes $7 an hour and works 22 hours, how much do Jack and Jill combined make in dollars in terms of R and H? So this is basically the same problem, but it's more abstract because we don't know the values for R and H. So we are going to have variables in our problem. So since Jack makes $7 an hour and works 22 hours, we can conclude that Jill makes what? 7 plus R, right? So let's put our B down here. So try to organize this here. So Jack, he makes $7 an hour. So that means Jill makes what? What did we just say? 7 plus R because she makes R more dollars an hour. So, and Jack's going to work 22 hours, but if Jill works H hours less, we know that her hours would be what? 22 minus H, right? So now we just kind of got to do the same thing that we were doing in A. It just has more variables in it. So I'm going to scroll this down here. So we're going to start off again. We're going to do 7. Oh man, that's a $sign per hour times what? 22 hours, just like before. Plus, now we got to do Jill's. So she's going to make 7 plus R dollars per hour, right? So I'll put dollars per hour times the number of hours she works, which would be 22 minus H hours. So now, we can simplify this down a little bit here. We can type in 7 times 22, and that gives us 154. And then we're going to have two binomials here, 7 plus R times 22 minus H. So that would be how much they would make in terms of R and H for that week.